week 7. It's the midterm, so you made it halfway. So probably you know where you start now. Another 7 weeks will be the end of the semester. Semester almost done. So we're good. So far you know how it goes. You got accustomed to the idea. For this chapter, if you have your book with you, it's good to follow through and see what are some of the equipment we're talking about. What we covered so far, huh?
What page?
It's going to be chapter 5, 6, chapter 6. Just follow through and look at the instrument. So far, we covered Ohm's law, power law. We covered resistances in series and parallel. We talked about basic electrical safety. We talked about how to use the multimeter. So I hope by now you feel comfortable using the multimeter, because with that you'll be able to go and troubleshoot electrical equipment. So far let's talk about components. Can you give me an example of electrical component that you'll see in HVAC? Brody, give me an example of an electrical component. Capacitor, thank you. Talking about capacitor, what is the unit? When we want to measure a capacitor, what is it called? Hold on. Lance.
Amps.
No.
Watts.
No.
Ohms.
No. That is very... Huh? We did it last week together. We measured the capacitor. What is it, Benny? No.
It was nanofarads.
Huh?
Nanofarads.
Yes. Farads or microfarads. This has a speed line in it. Excellent. Try to remember. Eric, give me another component.
Motor.
Motor. Looking at the motor has properties. Usually RPM. What does RPM stands for, Eric? Revolution per minute, or rotation per minute. What else? Joe. If you look at the motor, what would you see?
Horsepower.
Horsepower, thank you. Excellent. Also, what else? Marcus, torque.
Solenoids.
Solenoid is an equipment, okay. How do you spell solenoid?
SOLENOIDS.
NOIDS.
Yep.
So 3 O's?
No, there's
SOLE.
the middle O is an E.
Okay, Brandon, another equipment. Component.
Contactor.
Contactor.
Is solenoid a different thing from the list?
Solenoid?
Is it connected with that?
No. It's its own thing, basically.
They're similar, I guess, in the way they work, but
It's a coil with a mirror right inside, and you can open or close a button or pipe. Put up and down. Contactor, brand new contactor. Another component, Chris.
thermostat.
Thermostat. What is this considered to be as
Huh?
a switch?
Oh, switch.
Thermostat.
Relay.
What other kind of switch?
Relay.
Huh?
A relay.
Relay, could be a switch. It's also a large relay. So they say large in size, the book says size, but also the book says based on the amperage. Hunter, another component. Transformer. There you go. What does transformer do? You saw the big one where we put the screwdriver and make a spark. What is it doing? Transformer. Yeah? From high to low, low to high, right? Increase or decrease voltage. Fantastic. All right. Well, good. Let's continue. And next week when we do the lab, I'm going to give you a small board and a costat, and I want you to identify what are those components and what are they doing. So you will develop some kind of an idea what they look like, how they function. If you know how they function, you know what's going on with the equipment, which went wrong, and so on. So I'll continue the lecture. I'll keep it at 20 minutes, then I'll give you a break.
Hot.
Yes.
Can you turn on
Huh?
AC?
Is it again?
It's very hot. Can you turn on the AC?
Get over the door.
I
It is
thought I
very
turned
hot.
it down, but
Actually, it went up to 80.
maybe it's broken. Sounds like a problem. Yeah. Oh, yeah.
It is very hot. We gotta turn on the AC.
Only we had air conditioning right in the lab. Oh, wait,
There's more.
Thank you.
You're welcome. Human comfort is important.
True.
And this is the irony. This is the HVAC building and we don't have good AC. The irony.
What are you doing? You just open it up.
The AC is
Oh,
keep the door open.
not yet.
Okay, so let's start with heaters. We said heaters produce heat.
Yes.
Good. Chapter 6, EST-100. We're talking about components. This is week 7. Heaters produce heat. How do they do that? Basically, it's a coil. We've noticed that when you coil a wire, it produces heat. You can make your own.
Do magnetism?
Two. It's different property, but there's also magnetism going on. Two things go in the wire when you run current through them: magnetism and also heat. So heaters, they have improved a lot, and they look like a coil. If you look at your stove, there's a coil, and if you cut that coil, you see there's a small coil inside that coil that heats up. If you look at your incandescent light bulb, for example, this one here. If you look very closely, you will see a small little wire that is being coiled, like a spring.
Very inefficiency.
Huh?
Very inefficiency.
It's very inefficient. But when you turn on this light, this coil gets so hot, it starts to glow. And this is how we start to produce light. So usually when the light bulb goes bad, the wire inside is cut or burned out. And that's why, what's inside the light bulb?
What?
Huh? It's not air. Vacuum. That's why when you hit it, it pops.
Oh,
It's a vacuum. That's why it's spherical. So it can take the vacuum. So this is minus 14.7 psi. Why is there a vacuum in there? No. So it doesn't burn. Why does it burn? Yeah. That's a good idea too, because if there's gas, it will expand and maybe break the glass. But oxygen is the basis for burning. If we do not empty this bulb, it will burn. And if you notice, if you break the glass and turn on the light, it will light up for a slight second, then it burns out. That's why it's empty, because oxygen is a catalyst to burn the coil. So that's why it stays for a long time, because it does not burn. That's why also when you put these lights outside and start to leak, they burn out quickly. So this is some kind of a heater, and it gets really hot when you turn it on. So these are heaters. We use heaters in an AC. How? Or a fridge.
Oh.
Oh, okay.
Fridge and AC as well. Some AC have a heater coil in them, and some fridges have heater coils in them. Why? Guys in the back, phones off, Jason, Anthony, phones. I think. Why do we have heaters? Who's doing an ice machine? Defrost cycle, thank you. Defrost cycle. If you have a lot of ice built up, you need defrost cycle. Okay, this is what it looks like. Signal lights, those are very convenient to have. What do you think signal light is important for? If we have a circuit in series, it is nice to know if it's on or off.
Detect it, yeah.
Yeah. So it's an indication if the circuit is on or off. If you look at some of the new switching relay, it has some signal lights in it. Those lights are very small here, they're LEDs, but it's an indication that the circuit is on or off. So it's a good way for us to know. And if you look at equipment from the 70s or 80s, they didn't have a lot of signal lights, but it was kind of difficult to install. Now they have signal lights everywhere. And if you buy new equipment, they do not even have signal lights. What do they have? So if we look at the evolution, this is the primary control for a boiler. This was the first burner control. What does it have? One button.
Reset button.
And you go figure out what's going on with it. So it's more work. We have nothing, we know nothing of how it works, what's happening right now. We have to just do a lot of this work. Second, generation has one light and it has different flashes. Either it flashes fast, flashes slow, flashes even slower. So you can read what does it mean in here. So that was convenient and still probably in the market. Now, what do we have? It's the new one.
It shows, it reads
It'll tell you what's going
Yeah.
on there.
It will tell you, it has a display, LCD. It will tell you what's going on, the progress, give you messages. So it's way more convenient than the past ones. It eliminates the guesswork. And you don't have to go and read and find all the instructions inside. So that's good. So it's good also to upgrade. The prices are not that expensive anymore, so it's good to upgrade to something that will tell you what's happening, and they have also additional functions as well. So this is the purpose of signal lights. Contactors and relays, they are basically the same thing. They do the same function. So what do? They are switches, right? So they open and close sets of electrical contacts by action of a solenoid coil. So if we look at a relay, and we did test some relays last week. So it is solenoid. That's the coil over here. It goes on and off. So once you energize the circuit, you'll connect all the other circuits. And sometimes you can connect some circuits and disconnect others. For example, in the AC example, if I have, or the fridge, we have a lot of frost. I have a sensor that was able to see that there's a lot of frost. What happens? I will activate the relay. The relay, once activated, will disconnect the compressor and engage the heater. Otherwise, you're gonna have the heater and the compressor working at the same time, which you're gonna cancel each other. So sometimes you wanna cancel one circuit and engage the other circuit. Make sense? Yeah.
There's like a concept too, like with when they do the phones, like the tapping with the old style of communication.
No, that's different.
It's different.
That is different. I mean, it looks like it, but it's not.
Oh.
It's not. So, the other thing, if you have a heat pump, what does a heat pump do? Minister. What does a heat pump do? Yeah, so it can cool or heat. So it will, yeah, it will reverse.
Circuit breaker, like if it's too much, it
Yes.
just trips.
If you have forced air system, it will also turn on the furnace to heat the air and also turn on the compressor to cool the air. So it does both. If you have a wrong or faulty relay, you will turn on the compressor and the furnace at the same time. And this does happen sometimes. If you wire it incorrectly, it will turn on two circuits at the same time. So you have to have some kind of idea what circuit should be engaged and what circuit should be disengaged and why. Otherwise, the sub-circuits are not going to work correctly. So solenoids and contacts, when the solenoid is energized, contacts open or close depending on the original position. Something to remember. So when the solenoid is de-energized, we call that the normal state. So some relays are normally closed or normally open. What do we mean by that? When we energize it, when we carve the power, it will go to its default state. It's either closed or open. Please try to remember that. And some of the contacts, it will switch or reverse based on the state. So normally closed, normally open. The main difference between contact and relay is the size. Contactor is a simply large relay, and it's not the physical size, which is usually it is the physical size. But if you could ask the question in an electrical test, a contactor is more than 20 amps. Write that down. It's going to be at least in the next quiz or in the final.
Yeah,
Why? Because
okay.
they love this question in the when they test you for the test. So when you take the oil burn exam, it's 50 questions. 15 of those questions are going to be electrical. 15 is going to be around oil storage and oil problems. The other ones are going to be about controls. So it's 50 questions for the oil burn exam, and they try to touch base on basic knowledge. Questions?
So relay is less than 20, or is there a specific number?
Less than 20 is a relay. And double check in the book, because they'll say that. For me, I feel like they're all the same, but whatever.
Yeah.
They want to call it that, okay. So this, if you look at the contactor, this actually is a relay, even though they look the same, they have, the size is the same, but the amperage is different. If you look at the schematic here, that is the coil. And if you see those two terminals, this is normally closed or open. This is normally closed. So when they put the contactors on the sticker, they put it in this normal state when it's de-energized. Is this normally closed or open?
Open.
Open. And they have the number for those terminals. This is a relay. Let me see what is the, they don't see the amperage. That's a relay. That's a contactor, over 20 amps. And we did test the terminals. So you energize it from these two sides, it gets energized, and when it's de-energized, it will engage and will either open or close some of these connections. And we did test it for continuity. Contactors, they go back, they are a little bit expensive because they have a lot of voltage. And if they, you have seen how sensitive those contacts are. If they get dirty, they get something stuck in them, they will not connect voltage. Questions?
Yeah, how come the air conditioning turned off?
Huh?
How come the air conditioning turned off? It's still looking hot.
I don't know. How come it's off when it's so hot?
Yeah.
I don't know. I don't know.
Is that supposed to
Still
work?
seeing-
No?
Nah, we're doing the heat pump.
The temperature is still 81.
Yeah. It's, how do we turn the other one? Where's the remote?
Well, remotes are, no, is it?
Oh, turn it on.
Oh, is it over here? Is that it?
Very sorry. It's completely covered. Is it working?
Yeah, it is, there we go.
My system shuts down. I'm hot.
That's way better.
I'm just distracted right now. Otherwise,
The circuit trips.
so they all compose of three things. Contacts. Again, this is going to be one of the quiz questions, contacts, coil solenoid, and mechanical linkage. So those are the three things you have to check for. What could happen with the contacts? Just guess as a problem.
Corrosion, possibly.
Yeah, yes, thank you. They can corrode, they do not connect anymore. Rust is very insulating, as at least it does not connect as much as metal. What else?
Could be weak.
Could be.
Break off.
They can break off, build up, dust, moth, cobweb. A lot of things can happen to contacts.
Switch too many times, right?
Yeah.
Some contacts, they have switch rating. They'll be every rating needs to be switched back and forth, correct?
Yeah. Something to do with something. What could happen to the coil or solenoid?
Burn up.
Could be same rusted.
Rusted? What else, Betty? Did they burn out? How would they burn out?
Too much amperage.
Too much amperage. It get overheated. It rust. It get cut out. Many reasons to burn out. Mechanical linkage. That's the armature that runs before. It just breaks. That's easy. If you check a contactor and you hear rattling, the linkage is broken.
Okay.
Yeah. So it has to be replaced. Do we fix contacts or relays?
No.
No.
Why would you do that?
You replace them. In some expensive control, I don't care what. We clean the contacts sometimes, but you can replace some parts. Some of those contacts are very expensive on relays because they're vacuum sealed. They don't want to oxidize and so on. So this is some of the issues. Symbols, they're usually shown in the de-energized position. So as we saw before, but here, this is how it's connected in the de-energized position. Normally, that's the position of the contact when it's the device is de-energized. You know. Okay, so normally, that means what is the state of the contact when it's de-energized? Normally open, so it's not connecting electricity, there's no contact with region when it's de-energized. Normally closed, so when it's de-energized, this circuit is closed. What is its default state? Question about that? So normally means when it's de-energized. You cut off the power, is it closed or open? Got it? This is where those symbols are very common, but it could be different. And what do you do if you are not sure what is the symbol on that equipment? What do? You check what? Yeah, but if you want to look at the schematic, and you see different schematic. Huh?
What would you check for?
Yeah. If you look at a schematic, wiring schematics, and you see different symbols. So we know what that looks like. That's like a contact number.
Oh, you're
open.
gonna
Check the legend.
Check the legend. They do change it sometimes. I don't know why. European equipment have different legends, and so has different industries. If you work with electronics, they have completely different schematics. This could be the coil. Either this or that could represent a coil.
Yeah, 'cause
So, magnetic starter. What's a magnetic starter? It's a large contactor with overload protection. So it has more than 20 amps. It also has the ability to cut off the power based on a setting amperage. This is the symbol for it. And this one has 3 phase. And if we exceed a certain amount of amperage, it will shut off. How does it do that? It has a coil that will pull in the lever and shut it off. And you
So
have to
if
go
it
there.
goes over a certain amount of amps,
It will shut off.
And that's something you set, or is that something that's set?
It is set, you buy it the way it is, which is a good question. You do not want to buy another setting. It has to be the same. Plans on off. So, this is a magnetic starter. Where do we see that? In the big, large central layer, because there's a lot of power going through it. And you can hear it click. It's a very loud noise. And sometimes, okay, another question. When do you think it will trip? When do you require too much power? Why will it trip?
Because you overseeded the.
How? What is a situation where we will have to draw too much power? Huh? Startup, yeah. But in what situation? Exactly. Heavy load. So the motor is stuck, and the motor is huge, trying to turn a compressor, so it's gonna keep drawing power until it trips. If you don't trip, what will happen? It will go out, it will go out, it will burn, it will overheat. So it's a way to protect the motor or the compressor. Why would it be stuck? So many reasons. For a compressor, for example, probably Bill will tell you about that. For a compressor, what are the reasons that it will get stuck? A compressor is very similar to your car engine. Why would your car engine get stuck? See, no oil. And in our case, what lubricate the compressor? It has oil. Compressor also works with refrigerant. What if there is no refrigerant? It will stuck. What if it's lower refrigerant? Over time, it will overwork, and eventually it will get stuck. So, if the some compressor will get stuck, but once you refill the refiller, they will work okay, and some of them will not.
Is that the symbol for it in like a diagram?
Yeah, but again, you can look it up. It's not all the same, and you can see it has two connections here, and these are the contacts are normally open, contacts and are normally closed contacts. Okay, I will stop here and